All right, so going back to our understanding first of things from college algebra. So if we check out a parabola, we want to know, is it a function first? So the way that we test that, typically vertical line test, see if it passes. So here's my vertical line. If I slide it through, I see that it does pass, right? It's a function. It only hits at one point at a time. However, we want to know if it's one-to-one. We need to check if any y's are repeating. So do a horizontal line test. And we can see right away that it fails. We don't have to check too many points. One point that we can see here, right, 2, 4. Oh, excuse me, not 2, 4. Let's switch that to 4. 2, 4 and negative 2, 4. Right, so this function is a function, but it's not one-to-one. And why is that a problem? Because if we were to invert it, right, switch x and y, we can see now that the inverse isn't a function. So we do need our original to be one-to-one for the inverse to be a function. So what's a workaround that we have for this? Well, we say instead of taking the entire parabola, we're just going to restrict the domain. So let's just take it x greater than or equal to 0. Would it now pass the horizontal line test? It sure does, right? We only get 1 point at every intersection. So if we restrict the domain, our inverse will be a function. Let's check it out just to be sure. Confirm. Oh, it doesn't like that notation. The inverse would be the square root of x, but it'd only be the positive square root, not also the negative. And so we see now that the inverse is also a function. Awesome. So extend that idea to trig functions. So we'll start with sine of x. It is a function, but is it a one-to-one function? So if we are not sure, we can go ahead and use our horizontal line test from before. And we see pretty quickly that it fails the horizontal line test. We have repeating y's here for 2 different x's. And so to make it one-to-one, we're going to restrict the domain. So how do we restrict it? We just take, well, you're not going to be able to see that, but we'll just take those those endpoints here from negative pi over 2. Really, this should say less than or equal. Let's see, negative pi over 2 to pi over 2. And so now we have a nice, the inverse will be a function because our restriction made our function one-to-one. So now we graph the inverse and we get this function. Because our inverse and our original function will swap domain and range, the domain that we restricted here becomes the range here. It's not going to like that. It's going to become the range. And then the domain is going to be what the original range was. So that was negative 1 to 1. And so now that's the domain of arcsine. All right, so what's the point? The point is if I ask something like arcsine of 1/2, while there are 2 different places that this can be true, for instance, sine of pi over 6 is 1/2, and so is sine of 5 pi over 6. Those are both true. However, to make sure that we have a function for our inverse, we're going to restrict it only to the solution sine. It's only pi over 6 for when sine is 1/2. So to the question of, let's say, arctan of 1, there are 2 places where this happens. This happens at 45 degrees, and it also happens in the 3rd quadrant at 225, right? 225 degrees. This is true. However, you wouldn't say arctan of 1 equals 225. You would only say 45. So explore the other functions and you should be okay. Wish I didn't.